All right. So, good evening once again, guys. Uh, in past few sessions, we just discussed about the major VCR cycle components, isn't it? Especially the types of compressors, and we studied over the different types of compressors, such as the basic classification, which we discussed about positive displacement compressors, and the other one is a negative displacement, which means to be the centrifugal compressor and respectively and thoroughly we studied in which application we might need to use this kind of compressors, isn't it? That's also what we've been looked on that class itself. And later we just discussed about one more thing. I hope that should be the throttling devices, isn't it? So we just started over with the throttling devices, and I've been explained the working or the basic working principle of a capillary tube, whereas to the expansion valve itself, isn't it? Both are throttling device itself, but the working principle of a capillary tube is a bit different than that of an expansion valve itself. And we studied about the thermostatic expansion valve and how these load is getting controlled according to the opening and closing of the thermostatic expansion valve inside the circuit itself, isn't it? So these are the things that we've been hovered over the last few sessions. Am I right, isn't it? So on on the same topic itself, we got one more thing, which is the electronic expansion valve. All right. So inside this electronic expansion valve, the working should be still same, which means technically you will be having the same seat and needle arrangement right there itself. But in the case of a thermostatic expansion valve, the opening and close of that seat position should be done by the substance that you've been filled right inside the sensing bulb itself, isn't it? That means whenever the out temperature of the evaporator coil getting high than that of the normal situation, what will happen? The substance that should be right inside the sensing bulb started to vaporize, and it will pushes the diaphragm. That means more opening will happen, isn't it? Am I right? That's what we studied. And similarly, once the needle position is changed, of course, your condenser from the condenser side, more refrigerant flow will be there towards the evaporator itself, and that's how your room will getting cooled down within minutes, isn't it? So this is what we call as to be a load controlling across the room according to the cooling loads. All right. So whether in the case of an electronic expansion valve, or you can abbreviate it as to be EEV or EXV. Uh, So symbolically, these electronic expansion valves are used for more precise controlling and for the much more easier opening and closing of the valve according to the load. Okay, that means no delay will not be there for the opening and closing. That means an exact amount of refrigerant should be pumped over to the evaporator side itself when you will be installed an electronic expansion valve. So pardon, in this electronic expansion valve, you will be not having a uh, component like as to be this sensing bulb. Instead of this sensing bulb, you will be having a different kind of approach. That means probably a temperature sensor. That means, a small probe should be connected over the evaporator coil. Exactly the same sensing bulb right here itself. Now, instead of that substance, you will be filled right inside the sensing bulb. You will be having a small sensing probe. For example, like a thermometer. Okay, so here, as if the temperature exceeds a certain point that should be presetted on that specific electronic expansion valve, a small opening and closing will be there according to some kind of feedbacks. So here, in the case of an electronic expansion valve, you can see some kind of small motors like a stepper motor, and some kind of magnets will be there. So the working is very simple, as if the closing is required, which means closing or opening, They will simply change the polarities. That means, for example, if north and northern magnetic pole will contact it, what will happen? It makes some kind of repulsion, isn't it? So the same thing here also, if like north and north phase, what will happen? The seating should be opened. If north and south portion, the seating should be closed. So this is how a simply an electronic expansion valve works. And normally this electronic expansion valves are used preferably for a system called as to be VRF or VRV. And technically you can implement for chillers also. So this is the idea of electronic expansion valve. The other pushings and the same thing itself. Here, instead of pushing, that's directly an opening and closing. So that's why I told you, you don't you don't have to wait until the substance vaporize. Instead of that, it's a direct opening according to the temperature rating that you've been presetted on the same expansion valve itself. Okay, is it clear? Okay, now is it clear? Fine, I hope it's clear.
Yes, sir.
Okay, Shiva Prakash, is it clear?
Hi, sir. Just now I joined.
Okay, fine. So just go through the class itself, ma. It's a very simple topic. Not going in the list too far. Just a basic electronic expansion valve itself. Okay.
Okay, sir.
Any photo for same? Actually, Shami, I just closed right now itself. Once again, I will just once again I will show the electronic expansion valve. So you can see right here itself. I hope it's screen. Yeah, this is how this electronic expansion valve works. You can see this now. The permanent magnet and the needle and the seat and the thread and the shaft. So according to you can see the copper coils and stepper motor. That means, just changing the polarities, the rotation will be different. So it's like a simple rotation, like either it's clockwise or anti-clockwise. So in clockwise, the thread should be onto the seat. On the anti-clockwise motion, the thread should be from the seat itself, like from the needle to the seat itself. That's how this works. Is it clear? Is it clear, Shamir? I hope it's clear. So is there any doubts regarding with this electronic expansion valve? No, isn't it? Doubt illalo? Yerka doubt irka? Illalla? Excel, but I hope so. Again, please. Yeah, okay. So it's very simple working, ma. Here you can see this now. So just imagine this one itself. Here, in the other case, you will be actually having some kind of diaphragm, isn't it? That means, obviously the the vapor substance started to push. That's how an normal expansion valve works, isn't it? And thereby the seating should be opened. But in here, instead of that, you can see this now, this copper coils, like a simple motor arrangement here. So whenever the feedback reaches the copper coils, a small EMF is produced and thereby like a rotation will happen. So on this rotation, what will happen? The needle this is the needle, thread or needle. You can see right here itself now, needle, which means this one. So it should be gone to the downwards and upwards. This is the holder portion. So it's simply something related to that same thing itself. That means the opening and closing. For example, I can show it right here itself. The same thing we studied down now. So you can see this now. And here now, the same thing here. Here, it should be connected on the same motor shaft itself. That means the small stepper motor shaft. So if you change the polarities, the rotation direction will changes, like clockwise, and the other side should be anti-clockwise. So that's how the opening and closing will done. Is it clear? Shamir മനസ്സിലായോ? മലയാളത്തിൽ വേണോ? ഓക്കെ, ഇത്ര നേരം നേരം കണ്ടു. ഓക്കെ, ഷമീർ ഇത്രയേ ഉള്ളൂ, ഒന്നുമില്ല. നമ്മളെ എന്താ പറയുന്നത്, നിങ്ങൾ ചെറിയ മിനി മോട്ടർ കണ്ടിട്ടില്ലേ? മിനി മോട്ടറിനകത്ത് ഞാൻ ഈ പറഞ്ഞ സാധനം എല്ലാം ഉണ്ടാവും. ഓക്കെ, അപ്പം ഇതാ മിനി മോട്ടർ കൺസെപ്റ്റ് പോലെ തന്നെയാ. ശരിക്കും പറഞ്ഞു കഴിഞ്ഞാൽ നിങ്ങളിപ്പം നെഗറ്റീവ് പോളും പോസിറ്റീവ് പോളും ഇല്ലേ, അത് മാറ്റി കൊടുത്തു കഴിഞ്ഞാൽ ആ ഷാഫ്റ്റ് മേ ബി ക്ലോക്ക് വൈസ് ആയിരിക്കും തിരിയുന്നുണ്ടാവാം. അപ്പം ക്ലോക്ക് വൈസ് തിരിയുമ്പോൾ ഒന്നിൽ ഓപ്പണിംഗ് അല്ലെങ്കിൽ ക്ലോസിംഗ്, അതെങ്ങനെയാണോ നിങ്ങൾ കൊടുക്കുന്ന പൊളാരിറ്റിക്ക് അനുസരിച്ചിട്ടായിരിക്കും. ഓക്കെ, ഇനിയിപ്പോ അതുപോലെ തന്നെ നിങ്ങൾ പൊളാരിറ്റി ചേഞ്ച് ചെയ്യുകയാണെങ്കിൽ ഓബിയസ്ലി എന്ത് നടക്കും? നിങ്ങൾക്ക് അവിടെ എന്ത് ചെയ്യും? ഞാൻ പറഞ്ഞില്ലേ, ഇവിടെ നിങ്ങൾക്ക് ഈ പെർമനന്റ് മാഗ്നറ്റ് കാണാൻ പറ്റും. അപ്പൊ ഈ പെർമനന്റ് മാഗ്നറ്റ് ഉള്ള കാരണം കൊണ്ട് നിങ്ങൾക്ക് ആ ഒരു ഫ്ലക്ച്വേഷൻ, വിച്ച് മീൻസ് ആ റൊട്ടേഷൻ അവിടെ ഇനിഷ്യേറ്റ് ചെയ്യാൻ കുറച്ചുകൂടി എളുപ്പമായിരിക്കും. മനസ്സിലായോ ഞാൻ പറഞ്ഞത് ഷമീറിന്? ക്ലിയർ ആണോ ഷമീർ? ഓക്കെ, I hope so, because we don't have. Okay, fine. Shafiq, did you join right now itself, or you've been listening?
Yes, sir. Join in between some connection problem. Due to rain, I don't know.
Oh,
Joined
yeah,
again.
yeah. Right in Chennai.
Coimbatore only.
Ah, yo, yo,
CID.
yo. I seen that one. Okay, fine. Okay, stay safe, yeah. All right.
Yes, yes.
So,
Yeah.
whatever. So, this is the concept of an electronic expansion valve. I told you guys, it's symbolically. First of all, these whole connections should be inbuiltly comes alongside with your mission itself. So you don't need to worry about these kind of things. Okay. But just know the basic idea of how these each kind of elements works right inside the cycle itself. That's it. Next of all, we are going to studying about something called as to be heat exchangers. Okay. So what do you mean by heat exchanger? Go on, guys. What do you mean by heat exchanger?
Which transfers heat into cold and cold into heat. Something.
Yeah, that's the process
Any,
actually.
any
In
element,
simple words.
any element that transfers.
Okay, basically heat exchange, which means so one more thing. Uh, Among this process, which should happen inside a heat exchange? Is it a heat rejection or a heat absorption? What is happening right inside a heat exchange process? Tell me. Hello? No one? Any suggestions? That was right actually.
Rejection and heat absorption.
No, both. Yeah, that's it. That means both things will be happens right inside a heat exchange. That's how it got the name heat exchange, isn't it? That means in order to absorb something, it must need to reject something on the other side itself, isn't it? That's how this exchange works, like a barter system. Okay. So in each and every kind of heat exchanger, this is the same thing will happen. So as you said, that means an heat exchange will takes place like from high to low or low to high, whatever, both rejection and absorption will takes place. Okay. So this is a concept
Sir,
of
one
heat.
small doubt.
Hmm.
One doubt. Immediately after the condenser coil through expansion valve,
Hmm.
immediately the how it turns cold. I was just having
Okay.
after,
In which one? Like as you are asking for
after
capillary tube or expansion valve?
for the expansion valve only. Immediately
In,
after the crossing the valve, how it is turning it so cold
it's
immediately.
not actually
Before
going
it
to
was so
immediately.
hot.
It takes some time. That means like a small interval will be there. Here the volume is getting increased, isn't it? That's how
Yes.
you direct or throttling down your pressure. So I told you pressure proportional to temperature. That means whenever the pressure drops, at the same
Hmm.
time, the temperature also should be dropped down, isn't it?
Dropping. Oh,
That's it.
yes,
But
yes.
I told you in the introduction itself, while you consider capillary tube, it must be different because in there the working principle is about friction, isn't it? We just gone
Yes,
through, isn't
yes.
it? You remember? Yeah, that's it. But as in the
Yes,
case of an
yes.
expansion valve, it should be based upon the volume itself. Okay, we can see right here itself. Volume is inversely proportional to pressure, isn't it? That's it. So this is the concept of an expansion valves and the kind of things. Yeah, again, come on, guys. So in here, basically, there are different kind of heat exchangers are there. So the first type is a coil with fin arrangement. I hope you must been seeing this kind of arrangements, isn't it? Especially on the condenser side or even on the evaporator side itself. So typically, the concept of this evaporator and condenser are both same itself. That's what I told you. Both are termed as to be an heat exchanger itself. All right. That means in the case of condenser, the hot air should be rejected to atmosphere. That means initially the atmospheric air should be contacted with the coil with fins, and thereby a small heat exchange should be initiated in between them. And then due to the high temperature right inside the coil, probably most of the heat should be absorbed by the atmospheric air and it again rejected to the atmosphere itself. All right, clear. But whereas in the case of an evaporator coil, a heat exchange will take place between the room air and the coil structure. All right. So that's how you got the room has to be cooled low, isn't it? Or the cool down or settle down itself. Okay. Basically, coil with fin arrangements are preferred for liquid to air heat exchanging. That's how it's work. Okay. Liquid to air heat exchanging. Or simple words, It's an obnoxious thing, which means probably you can sophisticate some kind of vapors also. Why? Because initially at the condenser side it should be vapor format itself. So whatever, that's what they mentioned, this small symbol. You can see air to liquid, that means gas to liquid and liquid to gas. So basically it should be done with the coil with fin arrangement itself. And one more thing, coil with fins are basically meant to be, one second guys, one second. Okay, fine. Sorry. So basically, here, this coil with fin arrangements are preferred for only for air cool purposes. Okay, what it is for air cool purpose. So fine. Here you can see this is the coil structure, and you can see some kind of plates which is attached on top of to these coils. So what is the purpose of a coil? I hope I already explained the purpose of a coil. If you consider a coil, what will happen? The flow which the time, or the, what we can say, exactly the time, which means, it takes more time to getting exited at the out point of the coil structure itself, isn't it? That means we can prefer more heat exchange between the air. And one more thing you can see, this is the fin arrangement, and fins are used to increase the contact area. That means, as if the atmospheric air getting contacted with this fins, these fins can trap some kind of, these fin can trap the air right inside the gaps in between them, which initiate much more heat exchange, or which increases the heat exchange rate right inside the coil with fin arrangement itself. Okay, so this is the concept of coil with fin heat exchanger type. So preferably these kind of things are used for both, has to be a condenser side or either for the evaporator side itself. That's how this coil with fin arrangement works. While studying about the coil with fins, you also need to understand about the two factors, such as to be bypass factor and contact factor. So what do you mean by bypass factor and what do you mean by contact factor? And what should be the percentage that we are normalizingly taking for calculation purposes? So let's see. Here, this is the coil structure, isn't it? So let's consider 100% of air is getting passed over through this arrangement right here itself. However, the 100% of air will not getting contacted with this structure. That means a little bit amount of air should be escaped through some kind of gaps, isn't it? So those air, that means the air which will not be getting contacted with the coil structure, is termed as to be bypass factor. So that's why it is named as to be bypass. Okay, that means no contacting. It's escaping through those gaps right inside the arrangement itself. And the other one is contact factor, which refers to the amount of air which getting contacted with the coil structure. All right. So this is the concept of both bypass factor and contact factor. Generally, as I mentioned right now itself, in 100% airflow, the bypass factor is considered as to be 15%, whereas the contact factor is considered as to be 85%. Okay. I hope it's clear. Is there any doubts regarding with the coil with fin arrangement? And one more thing, mostly the material should be either copper or aluminium. Okay, either copper or aluminium. That's what we are actually using on the market itself. So you can see, this is what I told you. In the evaporator side, we already studied in VCR cycle itself, which means a conversion takes place from a liquid refrigerant to vapor refrigerant. And you can use also a shell and tube evaporator. I will explain the working of a shell and tube evaporator. Let's leave it though. In the condenser coil, a superheated vapor refrigerant should be converted over to hot liquid refrigerant. This is what happening right inside the condenser coil. All right, guys. So is the coil with fin arrangement is clear?
Clear, sir. This coil, when it is bent, it gets more time and also more.
Yeah, I
Just
told
gets
you
more
now
time.
that day itself. If you use a
Yes,
straight
yes,
pipe, what will happen? It readily goes to the other side. But
yes,
that's
yes.
not what I want. I need more time to stay the refrigerant right inside the coil itself, which initiate more heat exchange, isn't it?
More heat exchanges. Yes.
Because we need to brought
Okay.
back the
Yeah.
temperature of the refrigerant to the saturation levels itself, isn't it? To the saturation points. அதாவது அங்க இருக்கிற டெம்பரேச்சரை நம்ம ரொம்ப தூரத்துக்கு எடுத்துட்டு வரணும்ல கீழே. அப்போ நம்ம நிறைய டைம் உள்ள வச்சாதான் அந்த ஒரு ப்ராசஸ் அங்க நடக்கும். இல்லைன்னா உங்களுக்கு கன்வர்ஷன் நடக்காது. கன்வர்ஷன் நடக்கலன்னா நெக்ஸ்ட் எக்ஸ்பான்ஷன் வால்வுக்கு விடவும் முடியாது. ஸோ தட் இஸ் அன் இம்பார்ட்டன்ட் திங். ஓகேங்களா? அதனாலதான் நம்ம இந்த ஒரு கண்டென்சரா இருக்கட்டும் ஒரு இவாபரேட்டரா இருக்கும் இவ்வளவுக்கு ப்ரிஃபரன்ஸ் நம்ம கொடுக்கறதுக்கான ரீசன். ஓகே 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 அவினாஷ் அண்ட் சிவபிரகாஷ், உங்களுக்கு இது புரிஞ்சுதா? காயில் வித் ஃபின் அரேஞ்ச்மெண்ட்.
Yes, sir.
Okay, okay. I hope. I think Mrs. Rekha, isn't it? I think Vivo something. I don't know. Actually, உங்களுக்கு இந்த கிளாஸ் புரியுதா? Hello. Hello. I don't know even you're listening or not. Okay. I hope it's clear. Okay. Yeah, Shamir. Coil with fin mainly used for condenser only. No, no, no. Actually, I told you now. Coil with fin arrangements are used both for evaporator and condenser itself. Okay. Simple thing, wherever you need a heat exchange, and if you're preferring some kind of simple arrangement or even a complicated arrangement, you can prefer this kind of coil with fin arrangement. Okay. Actually, this doesn't prefer about the material or the cross section. It simply means to be the arrangement itself. Okay. Clear? Okay, Shamir, മനസ്സിലായോ? Shamir, മനസ്സിലായോ? Okay. Fine. All right. And the next type of heat exchanger is shell and tube heat exchangers. Okay. Shell and tube heat exchangers. I hope you've been seeing this kind of shell and tube. Probably not or may not. Whatever. I don't remember. So whatever, guys. Here, this is a very what we can say efficient type of heat exchanger right inside our market itself. That means, you know, the what do you call that? Yeah, COP, coefficient of performance. So while comparing this coil with fin to the shell and tube types, shell and tube is much more efficient one. Why? Because due to their high thermal conductivity and high heat exchanging ability. That's it. So this is a very simple arrangement, guys. That means symbolically you will be having a shell arrangement. So shell means that you'll be having a shell inlet and a shell outlet. Okay. And in between the shell, you've been installed your tube arrangements. What is this? Some kind of tube arrangements. So for tubes also, you'll be having a tube inlet and tube outlet. Okay. So here you can see this now. This portion should be the tube inlet and this portion should be the tube outlet. And this is for shell inlet and shell outlet. So now I'm not going to explain the full side working of a shell and tube heat exchanger. I'm just giving a small idea regarding with the shell and tubes itself. So basically here the working is much simpler than that you think, which means, you know, in our, like, you know, probably in our households, maybe, you know, some like kind of newborn babies or some, maybe like an even older baby, like a 5-year-old, 3-year-old, whatever, we've been giving them some maybe milk, isn't it? That means so instantly what we do, we heat up the milk, and in order to cool it down very instantly, we just pour the milk into a flat plate, and after that you will dip that plate on top of the water surface itself, isn't it? Then what will happen? You know, eventually the water will absorb the temperature of the milk plate, and later the milk getting cooled down within minutes itself, isn't it? That's how you've been done, isn't it? You remember. I'm not going to ask it because you know that this is the basic idea. So here, this is the same or the exact idea that we are adopting right inside a shell and tube heat exchanger also. That means uh, simply from fluid A to fluid B, a small heat exchange will happen. For example, in shell inlet, you will be providing some kind of fluid A, which is much cooler, and the other one is filled right inside the tubes, which is fluid B, and it is too much hot. So eventually, as per the natural law, from high temperature to low temperature, a heat exchange should be carried out, isn't it? That means initially the fluid right inside the shell started to absorb the temperature of the substance that you will be having right inside the tube, isn't it? So at the same time, you can see some kind of arrangement term dash to be baffles. The purpose of baffles is to create a turbulent flow across the shell structure itself. That means, if you don't install these kind of baffles, what will happen from the shell inlet? It should be directly outed to the shell outlet itself. That means we don't have that time. That's pardon. The heat exchanging efficiency should be lost due to the contact area, isn't it? That means here it's simply increasing the contact area to initiate much more heat exchange right inside the arrangement itself. So that's why we are preferring this kind of baffles. Okay. So is the shell and tube heat exchanger is clear?
Here, similarly, like the coil is bent, here baffles are bent.
Exactly. So you
So,
have you ever seen this kind of shell and tube evaporators in real life? It's like a huge, what do you call, huge
not
tankers. Okay. ரொம்ப பெருசா இருக்கும் ரியல் லைஃப்ல எல்லாம் பாத்தீங்கன்னா like
not seen.
first of all, one more thing, guys. Shell and tube heat exchangers, this doesn't means to be only for air conditioning purposes. Okay, you've been studied about thermal power plants, nuclear power plants. So inside those circuits, you've been seeing this one heat exchanger, isn't it? In some kind of flow diagrams. Actually, that's also the same thing, shell and tube. So preferentially, shell and tube is widely used where a kind of a heat exchanger across the industry itself. Not only for air conditioning purposes, we might be using this kind of heat exchanger wherever we need an heat exchange. That's the simple idea of this shell and tube. Okay, clear? I think thousands of tubes should be installed right inside the shell itself for some kind of nuclear power plants. Okay, is it clear? Any doubts on this shell and tube?
So this is for shell and tube is used in this chilled water supply tanks and all.
Exactly. That's it. That's it.
Okay, sir.
While discussing about
Okay.
chillers, you will definitely get the idea about the shell and tubes and how it's done.
Yes.
Because
Yes,
in
yes.
there we studied about at that topic, you might maybe studied about the refrigerant topics that I'm going to take after this 1 or 2 sessions right now itself. So that's it. Okay now. So in chillers, you'll be thoroughly getting the proper idea of the shell and tube and the entire chiller working.
The
Okay,
district cooling plant, I believe.
yeah, exactly.
District cooling plant, I believe.
District cooling, that's a huge thing, yeah. It's got like in Burj Khalifa, it's like 60,000, beyond 60,000 ton project it was.
There
And it
also
is
the shell and tube only.
exactly.
Shell and tube.
I told you now.
Oh.
Actually, one more thing will be there that is called as to be ETS, Energy Transfer System. That should be right inside the buildings.
Okay.
I will explain the district cooling later.
Okay.
Because lot much to study. Now we are not into the basic itself, isn't it? So once the basic is completed, we can go on to that kind of upgradational concepts. Actually, district cooling is an upgradational concept. Okay.
I've seen this cleaning only, cleaning of this tube.
Oh yeah, you see now. Okay. You can see the. Oh, fine.
I mean,
You can see the. I think the tubes are much more greater, isn't it? Like the size. Obviously, that like
yes.
normal.
Yes, sir. They use some equipment to
That's
with a brush
term
and
has
inside
to
to
be.
clean.
That's it. That process is called as to be chemical flushing.
Flushing, rotary brush, I think.
Rotary flush. That's it. Because in
Flush.
tubes, we might need this rotary flushing. I'm just explaining the entire process is called as to be chemical flushing.
Chemical flushing.
For the whole pipelines, including the shell and tubes. So that is meant to be a shutdown project or maybe a maintenance project, whatever. Okay, fine, guys. So this is the idea of shell and tube, which is chemical. What Shamira ഞാൻ പിന്നെ എടുക്കാം കെമിക്കൽ ഫ്ലഷ് ഞാൻ പിന്നെ എടുക്കാം ജസ്റ്റ് എന്നെ പിന്നൊന്ന് ഓർമ്മിപ്പിച്ചാൽ മതി പിന്നെ ഞാൻ ആ ചില്ലറൊക്കെ കഴിയുമ്പോൾ ഒന്ന് ഓർമ്മിപ്പിച്ചാൽ മതി ഓക്കെ ഇപ്പൊ ഞാൻ എടുക്കുന്നില്ല കെമിക്കൽ ഫ്ലഷിങ്ങിനെ കുറിച്ച് ഓക്കെ അല്ലേ ഷമീറെ അല്ലെങ്കിൽ ഇപ്പൊ എടുക്കണോ ഞാൻ ചില്ലർ എടുക്കുമ്പോൾ എടുത്താൽ പോരെ ഓക്കെ അല്ലേ ഷമീറെ ഓക്കെ ഇപ്പൊ ഞാൻ കെമിക്കൽ ഫ്ലഷിങ് എടുക്കുന്നില്ല സോ ഫോർ അതേഴ്സ് ഇസ് ഇറ്റ് ക്ലിയർ ശിവപ്രകാശ് ആൻഡ് അവിനാഷ് ഓക്കെ ഓൾ റൈറ്റ് ഷെൽ ഒരു ഐഡിയ കിട്ടാൻ ഓക്കെ ഞാൻ പറയാം ഒരു മിനിറ്റ് ഷെൽ ആൻഡ് ട്യൂബ് യൂസ്ഡ് ഫോർ ഹൈ ഹീറ്റ് എക്സ്ചേഞ്ചർ പ്രോസസ് ഇറ്റ്സ് നോട്ട് ലൈക്ക് ദാറ്റ് യാർ like I told you now, like it's not for high heat exchange. We can't say directly it has to be for high heat exchange or low heat exchange. Simply the idea is to initiate a heat exchange between two mediums. That's it. But you know, if you are preferring this shell and tubes, the heat exchanging efficiency should be comparatively high than that of other kind of heat exchangers. That's it. That's the only area. But you know, most of the industries are using shell and tube itself. Okay. Clear, Moiddin Badusha? புரிஞ்சுதா உங்களுக்கு ஐயோ தமிழ் isn't it? Yeah. Okay, fine. കെമിക്കൽ ഫ്ലഷിംഗ് എന്ന് വെച്ചാൽ ഒന്നുമില്ല ഷമീറെ അതായത് ഈ ട്യൂബിലകത്തൊക്കെ the concept is very simple here. Due to pardon, these shell and tubes are used for a long-term purpose, and the fluids may have some kind of properties such as to be corrosion, and due to the abrasion of the flow, which causes some kind of dust or some kind of rust particles along in the fluids, and at the same time, these fluids are treated with some kind of chemicals. So due to that chemicals, a small scaling should be formed right inside the tubes, shells. Okay. So that process is called as to be descaling process. And in order to do that, we must need to use a system. Sorry, we might need to use some kind of ideas just to be chemical flushing. That means we pour some kind of chemicals which will remove the dust and the rust particles, especially the scales from the inner surface and the inner walls of the shells, and even on the pipes also. Okay, and this process is termed as to be chemical flushing. മനസ്സിലായോ ഷമീറെ ക്ലിയർ ആണോ okay Rose Teresa ma'am clear and Selva who's this Selva
Yeah. I'm clear.
Clear, sir. Clear, sir.
okay. Fine. Selva, who is it today joined
No, I've joined from a different system.
Okay, your name?
Shanmuga Silvan Subramanian. So
Sorry?
Shanmuga Silvan Subramanian.
Oh, Shanmugam. Okay. Yeah, that's it. I just not your name.
Yeah.
Okay.
Yeah.
So how's your classes? Is it getting like okay na? Clear jane?
Yeah, okay. Yeah, clear.
Yeah, you Tamil, isn't it?
Tamil.
Yeah, okay, fine. Okay. If you're facing any doubts, just let me know right inside the class
Sure.
itself. Okay, now. Fine, that's it.
Sure.
All right, guys. So this is all about the shell and tube. So we studied about coil with nourishment, shell and tube heat exchangers, and the next uncommon kind of heat exchanger is termed as to be something called plate heat exchanger. So the delta T, you can see this now. Delta T means change in temperature. That means to be the heat exchange from fluid A to fluid B. So that delta T means change in temperature. Okay, that means what we can say the ratio or the rate, the heat transfer rate should be comparatively low on this kind of plate heat exchangers. Okay. Here also you will be using two liquid mediums. That means from liquid 1 to liquid 2 heat exchange will take place. Here, instead of tubes, you will be using some kind of plates, some kind of flat plates, and the thickness of the plates should be around like 1 mm, 2 mm. That means much more thinner plates. Okay. And I think this animation should clear your doubts. You can see this now. A fluid is entering into this plate right here itself. on the bottom, you can see it's very cold. That's why it got the color as some kind of dark blue, isn't it? But at the same time, on the very adjacent plates, and another fluid is flown across on this plate itself. And you can see the color is very red hot initially, but eventually the color of this substance became as to be white, isn't it? That means an heat exchange is takes place between these two plates right there itself. For the and you can see the result. It has to be this cold water lost its credibility, which means it's lost its coldness due to the heat exchange in between the adjacent plate, isn't it? You can see at the end of the animation, the water will became, it has to be some kind of white color. That means it's lost its coldness. That's it. So that's how these plate heat exchangers work. Typically, plate heat exchangers are preferred in industrial purposes. That means in order to cool down the hydraulic coils in certain things, I hope, yeah, in those areas, you'll be using this kind of plate heat exchangers. But still, this plate heat exchangers are much more preferable to the industrial side itself. But in air conditioning also, we are using this kind of plate heat exchangers. Okay, now, I think in higher projects, especially chiller-based projects, and some kind of what we can say, yeah, especially for VCR cycle-based chillers, and for especially for in cold room, not cold room, for industrial air conditioning purposes. Okay, for industrial air conditioning purposes, we will be using this kind of plate heat exchanger right there also. All right. So is it clear? Is the plate heat exchanger is clear?
So this is for cooling or heating?
Exactly the
This,
same thing, yeah. Cooling itself.
both.
That means I told you,
Only
we need
only
to
cooling.
remove a heat from one object. That's it, or a one substance. For that one, I'll be using another medium which is lesser temperature than that of that medium itself. Okay. Clear? Vunujida Shafiq?
Okay, so the
No,
red color on the top, liquid, red liquid, I don't know.
ரெட் லிக்விட் வந்து ஒயிட் லிக்விட் ஆகுறதுக்கான ரீசன் அதோடைய ஹீட் வந்து விச் மீன்ஸ் அதோட டெம்பரேச்சர் டிராப் ஆயிடுச்சு. தெரியும்ல, நேச்சுரல் லா படி நீங்க பக்கத்துல வச்சிருக்கும் போது லைக் இட்ஸ் நாட் கெட்டிங் கான்டாக்டட். ஓகே, பட் a slight adjacent gap will be there in between them. Okay, like a 1 mm gap, 2 mm gap in between them. Like this is the picture of the plate heat exchanger. You can see this now. This is how these plates are closely packed. Okay. Okay, then. So this is the inlet and outlets. You can see the inlet and outlets for both mediums.
Okay.
So, okay, now that's it.
Hmm.
Shamir run that out now. The concept is just like radiator. Oh, yeah, exactly. We can simply set it like that way also. Yeah, that's it, ma. But actually, radiator, paraya. But radiator is also, I think it's it's similar. Actually, radiator or plates are. Yeah, you can consider for cars, okay, not in bikes. Especially in cars, you can consider. Okay, Moidin. Whatever you are comparing, it's very good idea. Whatever, just go ahead like that way itself. Okay, now. Okay, so is there any doubts on this plate heat exchanger? No, isn't it? I'm just asking again just to know that.
Sir, ஒரு last doubt, sir. Correct கேட்டுக்கேன்.
சொல்லுங்க.
மேல ரெட் போறது இன்னு, வெளிய ஒரு
ஆமா.
கூல் அவுட். இதான் ஒரே ஒரு doubt. Only that doubt.
Go on.
Red is in and the bottom blue is out.
No,
Is
that's
that
not.
motion?
No. One second. This red comes like this way and goes like this way. Okay.
Oh.
Okay, and this blue comes like this way and goes like this way. Okay.
Okay.
இதுக்கும் மிக்சிங் கிடையாது. That's the idea. Okay na?
Okay.
இந்த பிளேட்டோடைய ஐடென்டிக்கல் பிளேட்டுக்கு தான் கனெக்ஷன் இருக்கு. ஓகேங்களா?
Okay.
அதே மாதிரி இந்த பிளேட்டோடைய ஐடென்டிக்கல் பின்னுக்கு தான் அதோட கனெக்ஷன் இருக்கு. ஓகே. அதான்
blue
ஒரு
goes in, goes
இன்னொன்னு
out.
கூல் பண்றேன்.
Okay, sir.
Okay, I hope
Sharing,
it's
sir. Okay.
fine. So comparatively, if you just consider your coil with fin, these plate heat exchanger and shell line tubes are much more costlier. Okay, that's the one thing. And the other kind of heat exchanger is termed as, or we can call him Mr. Cooling tower. So you've been heard about this cooling tower concepts, isn't it? Basically, there are two kind of cooling towers are there, which is a natural draft cooling tower, and the other one is mechanical draft cooling tower or induced draft cooling tower. Natural draft, which means it's something, in simple words, I can say it as like an chimney. Okay, in our homes, if you are using some kind of like what do you call the wooden based, what are we calling this one? Adupu, that's how you call it, isn't it? So you can see those kind of chimneys should be attached along with that hearth itself, isn't it? So these concept of chimney is very simple. The hot air or the smoke should be obligately getting escaped through that chimney to the atmosphere itself. So that is meant to be natural draft, and probably the flow rate, the velocities should be comparatively low on this kind of natural drafts based cooling towers. Especially it is used some in thermal plants, or yeah, thermal power plants. You been seen that one in Chennai, not in Chennai, I hope. Chennai இருக்குன்னு நினைக்கிறேன். I think in I don't know, remember the place actually. I hope in Chennai we having some kind of in a remote place, I hope. Okay. So here, what I shown right here itself is meant to be a induced draft cooling tower. So I will explain the work. Suppose I need a medium to, or otherwise, for example, I need to brought back a medium to atmospheric levels. So for that application, I can go for a cooling tower. For example, you've been heard about this thermal power plants, and after rotating the generator, the turbines, not generator. After rotating the turbines, the steam should be carried across in a high pressure and high temperature liquid format itself. It should be condensed back, isn't it? And these liquids are subjected to a cool down process, and that should be carried right inside the cooling tower itself. That means, these warm waters, that is meant to be this water which will be collecting from the outletting of those turbines itself. So these warm waters are subjected across the cooling tower itself. So you can see this is meant to be the water distribution, and these are the nozzles should be attached. So the warm water should be sprayed across right inside the cooling tower arrangement. And you can see some kind of arrangements are made right inside the cooling tower, is named as pack or fill. At the same time, on the sideways, this is the air intake. So you can see this is the air intake portion. So in the air intake, the atmospheric air should be entered through this side, but it can't be escaped on the same side itself. It should be only rejected through the top side. That's why we've been installed a fan. Okay, you can see this is the top discharge axial fans. What is it? Top discharge axial fans. So these top discharge axial fans should be placed on top of this cooling tower itself. Okay, now. And after that, you can see right here itself, some kind of drift eliminators are there. So I will explain the working. It's very simple, guys. The water should be sprayed in a mist format itself, and these water mist should be getting contacted with the pack or fill arrangement. So eventually, as you know, through this pack arrangement, the temperature of the water getting dropped down due to the atmospheric air intake right here itself. So eventually it should be end up right at the bottom of this cooling tower, which is named as the collecting reservoir. Okay, so that's at the same time on the top side, you can see with the help of this top discharge axial fan, the temperature or the hot air should be rejected continuously to the atmosphere itself. Okay, we know, guys, we've been spraying the water right inside the cooling tower itself. So there might be a chance of water droplets maybe escape alongside with the hot air itself, isn't it? So in order to maintain the water level right inside the cooling tower, they will fairly packed with some kind of drift eliminators. Okay. So satisfactorily, this drift eliminators will condensate the water droplets or the water vapor or the moist right inside the escaping hot air. Okay. So that's the purpose of drift eliminators. And these condensed water should be again fall over to the pack arrangement and then to the collecting reservoir. So is it clear? So once again, guys, these drift eliminators are used to condensate back the water or that medium without escaping through the hot air outlets. Okay. Why? Because, due to the suction side, isn't it? This is the back portion. So while the water is being misted along across the cooling tower, there is a high chance of, due to the suction, the water mist can be readily gone along with the hot air itself. So in order to hinder that, that's why we are implementing this kind of drift eliminators. Okay. I hope I will show the picture of this drift eliminators. Sorry. So actually these pack or fills are meant to be some kind of PVC material, like a thin, like a coated fabric material. You can see this now. This is how this packs should be looks like. Can see this now. Can see? First of all, it's a porous structure. That means it should be intertwined some kind of porous connections. So eventually it should be fouled off to the bottom side of the cooling tower itself. Okay now. So this is meant to be the pack arrangement. Okay. So this is one type of pack arrangement. So I hope it's clear. So at the end of the connection, you will be getting a cold water. So this cold water doesn't mean I will be having a temperature around like 5 degrees, 6 degrees. No, it's not. Actually, the outletting temperature should be probably like 25, 26, 28. That means same as per the atmospheric temperature itself. Okay. So you can see this now, hot water in, and it should be sprayed, but at the bottom side, you'll be getting a cold water. And it should be treated with the dry air, which means atmospheric air itself. You can see this now, moist and warm air out. However, you will be placing these drift eliminators. Definitely, there should be a loss of water will happens. Okay. So in order to reduce that factor, that's why we've been placed this kind of drift eliminators across that cooling tower itself. Okay. So is it clear? Hello? Is it clear, guys?
Yes, sir.
டவுட் இருக்கா பாதுஷா? இது புரிஞ்சுதா? நீங்க
இல்ல
படிச்ச
sir.
விஷயம் தானே?
புரியுது sir.
ஓகே ஓகே.
புரியுது sir.
சிவபிரகாஷ், is it clear? ஷஃபீக் டவுட் இருக்கா? இல்ல. Okay, come on. Yeah, fine. All is good. Okay. I think for yeah, ഷമീർ മനസ്സിലായോ മോനെ? ഷമീറിന് ക്ലിയർ അല്ലേ? ഡൗട്ട് ഉണ്ടോ അതില്? So that if you are placing a fan, so that is meant to be an induced draft. That's it. There is no fan. That is meant to be a natural draft cooling tower. So I will show the natural draft cooling tower picture. You've been might seen on these games also. Some kind of PUBG, I hope so. But I show this one, natural draft. You can see this now. Not here. Yeah, this one. You've been seeing this on games also, isn't it? This is a natural draft cooling towers. That means it's probably for high like industrial areas. It's not
Yes,
used
I
for
guess
some
this is
kind of
used in power plants.
yeah, especially power plants that I told you in the
Power plants.
initial session
Fossil
itself,
power.
which means probably for thermal power plants, nuclear
Yeah.
power plants, but still in nuclear power plants, if the moderator is radioactive, they will not use this direct emission. Okay. So there are different kind of the shape is termed as to be hyperbolic. That's it. Okay. You can see this now. Hyperbolic, which means this shape. That's what it is. You've been heard about parabolic, isn't it? The other one is hyperbolic. That's it. So is the basic idea is clear? Okay now. I hope it's clear though. All right, guys. So can we jump on to the next topic? Okay. Again, I told you now this pack is also called as to be corrugated sheet. That means, it increases the contact time between water droplet and air. That's it. Okay, now that's it. So this is the end of our component study. That means we studied about compressors, heat exchangers, throttling devices, isn't it? Next of all, we will be hopping over to the other one, which is termed as to be refrigerant study. Okay, so refrigerant study. So before that, what do you mean by a refrigerant? Tell me, guys. I'm not showing anything. Okay, now just in the slide right here itself. What do you mean by refrigerants? Tell me. Any idea? No. Have you ever heard about refrigerants in day-to-day life? Anyone can answer, yeah. No need to
Yeah,
shut
sir.
up.
In EDC, we are using refrigerants to make
Ah,
cool.
cools or heat, isn't it? So symbolically, uh, refrigerant means to be, first of all, it's a substance. Okay. So actually, this is the working medium right inside in your refrigeration cycles, which delivers the heat or sorry, hot or cools or heats or cools the room according to your need. Okay. So this is the medium which will initiate the heat exchange and the other kind of things. And this is the specified working agent right inside your refrigeration cycle. Okay, so we've been studied the definition of refrigeration, isn't it? The heat transfer from a low temperature region to high temperature region with an external load. So in order to deliver this heat from low temperature to high temperature, we need a medium, isn't it? And that medium is termed as to be refrigerants. Okay. Generally, there is a basic classification is there for the refrigerants. Refrigerants are mainly classified into two. So before going into the refrigerant study, we might need to study the good properties of a refrigerant. Okay, we might need to study the good properties of a refrigerant. So if you are going to choose a refrigerant, the first property should be, or general properties of a good refrigerant should be non-toxic, non-explosive, non-poisonous, non-flammable, and it definitely a stable gas. At the same time, should it need to operate even at lower pressures and non-corrosive, and it definitely have to be a low boiling point, low freezing points, and the viscosity also should be low. Otherwise, what will happen? It should be stuck around the pipelines itself, isn't it? Or in the circuit itself. And the other property should be high thermal conductivity, and it definitely not to undergo any chemical change across the working. Okay, so that's how, or that is the good properties of a refrigerant when you are going to choose a kind. Okay, generally refrigerants are classified into two, which is a primary refrigerant and secondary refrigerant. Primary refrigerants are used in DX systems. DX stands for direct expansion systems. Okay, what is it? Direct expansion system. And secondary refrigerants are used in for a chilled water system. Okay, so there should be primary refrigerants and the other one should be secondary refrigerants. Primary and secondary. Primary used in direct expansion systems and secondary used in chilled water systems. Okay, so this is the basic classification of refrigerant. Once again, primary refrigerants are again subclassified into three different groups, which are natural refrigerant, synthetic refrigerants, and the last one is blends. Okay, so natural, synthetic, and blends. Not showing anything. What is direct expansion system? A medium using for, okay, that's it. What is direct expansion system? Yeah, I will explain the concept of direct expansion system while on the upcoming session itself, which means on the machine study. Okay, direct expansion system is nothing but the primary refrigerant will cool down the rooms or that space itself. That's what you mean by a direct expansion systems. Okay. But we having much more controversies along with the direct expansion systems itself. So we can learn eventually on the path itself on the upcoming sessions. Okay, so here basically primary refrigerants are used as to be in direct expansion systems, and the secondary refrigerants are used in chilled water system. And again, I told you, primary refrigerants are again subclassified into three different groups: natural refrigerants, synthetic refrigerants, and blends. Okay, okay, so this is clear. Fine now. So the first one I'm going to explain about natural refrigerant. What do you mean by natural refrigerant? Natural refrigerant, which means it can be obtained directly from the atmosphere itself, which means from the surroundings itself. So that is meant by a natural refrigerant. That means it can be obtained by its original phase itself, isn't it? So that's what you meant by a natural refrigerant. So there are a lot of examples are there for this kind of natural refrigerant. Now I'm going to start over with the natural refrigerant, which is much familiar for you. First one is ammonia. Okay, so almost I explained a little bit data of ammonia while I take the VAR class, isn't it? VAR refrigeration, isn't it? On that topic, I explained about the physical and chemical characteristics of ammonia itself, isn't it? So actually, ammonia is a good refrigerant. That means the thermodynamic efficiency or the thermal efficiency of ammonia is very high. So it can be used as a refrigerant. But there is a problem is there. Okay. There is a small problem with ammonia. So I will explain what is the problem. So ammonia is a natural refrigerant and it can be considered to be the most efficient type of refrigerant. And it is one of the only original refrigerant still in use today. That I told you, ammonia is the only original refrigerant, which means that the natural format or the natural formed refrigerant is meant to be ammonia itself, with having a high thermal efficiency. But there is a small problem with ammonia, so we can discuss it. Actually, as per the ASHRAE classification, I think that is a ASHRAE standard 34. Okay. So as per ASHRAE standard 34, there is a slight classification among the refrigerants are there, which is meant to be the entire refrigerants are classified into 6 different groups. Okay. Which is A1 refrigerant, A2 refrigerant, A3 refrigerant, B1 refrigerant, B2 refrigerant, and B3 refrigerant. A1 refrigerant, which means these are the refrigerants which will having low toxicity and low flammability. That means least hazardous refrigerant. Whereas the B3 refrigerants are the B3 refrigerants are termed as to be the highest hazardous refrigerants, which having high toxicity and high flammability. So as per the consideration of the ASHRAE standard 34, ammonia is included as to be a B2 type refrigerant itself, which means it's having high toxicity and low flammability. So that is the problem. That means we can't use ammonia directly inside the refrigeration cycles, especially for the building side. So if you are using ammonia, you might need to consider the safety precautions of ASHRAE standard 15 in order to use this kind of toxic refrigerants as to be the working medium across the refrigeration cycle itself. Okay, is it clear? Okay, now, so this is the basic idea of ammonia. And however, ammonia is widely used in industrial application because of its excellent thermodynamic performance. But still, in building and the fire and hazardous materials codes apply limitation because of safety concern, which means across this building side and this one, ammonia is not preferable mostly due to its safety concern. Okay, so this is the basic idea of ammonia. Actually, according to the again the same thing, ASHRAE ASHRAE standard, refrigerants having some kind of names or refrigerant names. So as per the name, ammonia is assigned or ammonia is abbreviated as to be R717. Okay, R717. Okay, so that is the abbreviation name of ammonia. Clear? Okay. I hope so. Is it clear, guys? R717 stands for ammonia itself. Okay. Is it clear? So this is the introduction that I would like to give for today. I think it's enough for today itself. Tomorrow, we can start over with the remaining session. One more thing, guys, just intimidate me tomorrow about the thermodynamic study of refrigerants. Okay, that's not important though, but I thought it should be helpful for you. Just a recalling class. Okay, just remember me, or sorry, just intimidate me in the next class itself, according to the refrigerants thermodynamic ideas. Okay, now. So, any doubts, guys? It's gone.
So one quick request. So can you also share the PPT files that you have been?
Yeah. So if you don't mind, can you mention Mr. Nasif and ask that thing directly himself itself? So
Okay.
it should be more helpful for me. Okay. If he gives a green card, I should definitely send those to you. Okay, now.
Okay. Yeah.
Okay. Cooling tower മനസ്സിലായില്ലേ ഷമീറെ? Okay. Cooling tower എന്ന് വെച്ച് കഴിഞ്ഞാൽ എത്രയേ ഉള്ളൂ. Okay. That's very simple. ചൂടുവെള്ളം വരുന്ന നമ്മൾ ഇങ്ങനെ ഡയറക്ട്ലി ഇതിനെ സ്പ്രേ ചെയ്യുന്നു. അപ്പൊ സ്പ്രേ ചെയ്യുമ്പം ഇറ്റ് ഷുഡ് ബി കൺവേർട്ടഡ് ലൈക്ക് എ മിസ്റ്റ് ഫോർമാറ്റ് അല്ലെ? നോസിൽസ് വെച്ച് സ്പ്രേ ചെയ്യുമ്പോൾ അത് മിസ്റ്റ് ആയിട്ട് പോയി താഴത്തോട്ട് ഈ ഫില്ലോട്ട് ഇങ്ങനെ ഇറങ്ങി താഴെ ചാടി താഴത്തോട്ട് എത്തും. അറ്റ് ദ സെയിം ടൈം നമുക്ക് കാണാൻ പറ്റും സൈഡിൽ നിന്ന് എയർ ഇൻടേക്കും വരുന്നുണ്ട്. കണ്ടോ? ഇത് കണ്ടോ? ഇപ്പം നമ്മുടെ സൈഡിൽ കൂടെ അറ്റ്മോസ്ഫിയറിക് എയർ കയറുമ്പോൾ ഓബ്വിയസ്ലി അതിന്റെ ടെമ്പറേച്ചർ ഡ്രോപ്പ് ആവും. ഞാൻ പറഞ്ഞു മുകളിൽ ഒരു ഫാൻ വർക്ക് ചെയ്യുന്നില്ലേ? അപ്പം ഈ ഫാൻ എന്ത് ചെയ്യും? ഉള്ളിലിരിക്കുന്ന ചൂട് മൊത്തം എടുത്ത് പുറത്തോട്ട് റിജക്ട് ചെയ്യും. ഈ കൂടെ പോകുന്ന എയറിന്റെ ഒപ്പം എന്തും കാണും, ഇച്ചിരി വെള്ളത്തിന്റെ അംശവും കാണും. അപ്പം അത് നമ്മൾ കുറയ്ക്കാൻ വേണ്ടിയിട്ടാണ് നമ്മൾ ഡ്രിഫ്റ്റ് എലിമിനേറ്റേഴ്സ് നമ്മൾ യൂസ് ചെയ്യുന്നത്. ഓക്കെ അല്ലേ? അപ്പം നമ്മൾ ഡ്രിഫ്റ്റ് എലിമിനേറ്റേഴ്സ് എന്ത് ചെയ്യും? ആ ചാടി പോകുന്ന വെള്ളത്തിനെ അങ്ങനെ തന്നെ കണ്ടൻസ് ചെയ്ത് തിരിച്ച് താഴത്തോട്ട് തന്നെ അയക്കും. അങ്ങനെയാണ് നമ്മൾ ഈ താഴെയുള്ള റിസർവോയറിലെ വെള്ളത്തിന്റെ ക്വാണ്ടിറ്റി നമ്മൾ മെയിൻറ്റെയിൻ ചെയ്യുന്നത്. എന്തൊക്കെ പറഞ്ഞാലും അവിടെ ലിറ്റിൽ ബിറ്റ് ഒക്കെ ഉണ്ടാവും. എന്നിരുന്നാൽ പോലും നമ്മൾ ഈ ഡ്രിഫ്റ്റ് എലിമിനേറ്റേഴ്സ് എല്ലാം മാൻഡേറ്ററി ആണ്. മനസ്സിലായോ ഷമീറെ? മനസ്സിലായോ? Okay, fine.
Sir, which area it is cooling?
ഏതുമാ?
This tower. The cooling tower.
புரியல
Where it
எனக்கு.
is going
என்ன
on?
ஏரியானா?
The process is clear. But,
எங்க யூஸ் பண்றாங்கன்னா?
எங்க யூஸ் பண்றாங்க?
அதான் நான் சொன்னேனே, தெர்மல் பவர் பிளான்ட்ஸ்ல இந்த மிச்சம் மீதி வர சுடு தண்ணியை டைரக்டா அனுப்ப மாட்டாங்க. இல்லனா ஈவன் நான் உங்கள்ட்ட VAR சைக்கிள் எடுத்தேன்ல, ஞாபகம் இருக்கா? இன் VAR சைக்கிள் I just explained something called as to be condenser. ஞாபகம் இருக்கா? அங்கே ஒரு கண்டென்சர் இருந்திருக்கும். அப்ப கூட நான் சொல்லியிருப்பேன் அதுக்குள்ள ஒரு கூலிங் காயில் தான் இருக்கும்னு சொல்லியிருப்பேன். ஞாபகம் இருக்கா? You remember? VAR சைக்கிள்ல ஒரு கூலிங் காயில் இருக்கும்.
Everything is clear. My question is different. Like where is the indoor? Where is the
No
indoor?
indoor. Like இது இன்டோர்னு இல்லம்மா. இப்போ உங்களுக்கு ஒரு
அதுதான் என்ன
சுடு தண்ணியை
purpose னு கேட்டேன்.
அதான் இப்போ ஒரு சுடு தண்ணியை உங்களுக்கு கூல் பண்ணணும்னா you should go for a
Okay,
cooling
okay.
tower. ஓகேங்களா?
That's it.
அவ்வளவுதான்.
Okay.
That's it.
Okay.
அது
Okay.
சுடு தண்ணின்னு கூட இல்ல, எந்த ஒரு சூடான மீடியத்தையும் கூல் பண்றதுக்கு உங்களுக்கு கூலிங் டவர் யூஸ் பண்ணிக்கலாம். ஈவன் நான் சொன்னேன், இப்போ டயர் மேனுஃபேக்சரிங் கம்பெனிஸ்ல வெளியே கூலிங் டவர் இருக்கும், பாத்திருப்பீங்க நீங்க. வெளியே ஸ்ப்ரே மாதிரி போய்கிட்டே இருக்கும் தண்ணி, பாத்திருக்கீங்களா? ஓப்பன்ல இருக்கும் அது. அந்த தண்ணி இதுக்காக இந்த கூலிங் பண்ணுவாங்கல்ல, இந்த அன்னீலிங் ப்ராசஸ் எல்லாம் இருக்கும். அதாவது டைரக்டா இந்த ஃபார்ஜிங் பண்ணிக்கிட்டு தண்ணியில முக்குவாங்க, பாத்துருக்கீங்களா? இல்லைன்னா ஈவன் ஆயில்ஸ் கூட முக்குவாங்க, டிப் பண்ணுவாங்க அந்த ஒரு மீடியத்தை, இல்லைன்னா அந்த ஒரு மெட்டீரியலை. அப்போ அந்த தண்ணி நல்லா சூடாகும். அந்த தண்ணியை கூல் பண்றதுக்காக யூ கேன் கோ ஃபார் எ கூலிங் டவர். தட்ஸ் இட். ஆல் ரைட். So is there any doubts regarding this one? Hope it's clear. ஷண்முகம், உங்களுக்கு புரிஞ்சது இல்ல கிளாஸ்? டவுட்ஸ் இருக்கா இதுல? No, isn't it?
இல்ல doubts இல்ல.
Okay. Fine. Okay. So, ma'am, is it clear?
Thank you.
Yes, it's clear, sir.
Okay. Doubt ഉണ്ടെങ്കിൽ പറയണേ. Like എനിക്ക് മനസ്സിലാവുന്നില്ല നിങ്ങളുടെ ഡൗട്ട്. Okay, fine. Okay, ഷമീർ, okay, എല്ലാം ക്ലിയർ അല്ലേ? ഇന്നത്തെ ക്ലാസ് ഇത്രയ്ക്ക് മനസ്സിലായോ? Because tomorrow ഞാൻ പറയുന്നത് refrigerantsന്റെ remaining അല്ല. It's not the remaining of refrigerant, probably going to the thermodynamic study itself. That's why. Okay, now. So, okay, guys, I think it's enough for today. We can wind up our session. I will catch you tomorrow. Bye. Have a great day, guys.